Good morning, guys. Um, Today is last lecture for active and reactive powers chapter. And today we will learn about the short circuit currents of a characteristic in a synchronous generator. We will learn a little bit deeply about this. Let's see. So we divided to transient period and transient period and steady state period. But with this, we cannot explain with Ohm's law. You know what I mean? So let's see. First of all, oh yeah, I forget it here. It's not looks like this, but sub-transient periods, the current's magnitude is almost between uh, 5 to 10 times more, bigger than steady state period. This picture is not looks like that, but what I mean is general terms. You know what I mean? Yeah. And then this is our diagram for the synchronous generator. First of all, we need to see here rotor, right? It's sharp to here, and then we rotating here, right? For example, 36 RPM. RPM, sorry. And then we control here IF is with the DC excitation, right? With the rotor winding, field winding, right? And then here is just state part outside here, right? And state winding is here, right? And damper, we add damper, for example, damper here. So first of all, what is a damper? Damper is we use okay, for example, in this case, synchronous means, the rotor's rotating field, and then the stator winding, it makes also revolving, revolving field. It also make, right, from the stator winding, right? But what I mean, the synchronous means from the stator part, it make it, revolving the field, right? And then the rotors, rotor itself also revolving, right? If it's the same, they are same, we say synchronous, right? But what I mean is, if it didn't, yeah. So sometimes, the speed is always cannot be same, little bit different. You know what I mean? It could be a go down or it could be a go up. You know what I mean? So tempers working as a breaker or as an axial rotation. You know what I mean? To match the speed same. You know what I mean? And in synchromotor, it doesn't have the torque, start torque. So that's why the dampers winding also works as induction motors, winding. You know what I mean? Yeah, this is a basic concept. You know what I mean? Yeah, but between, yeah, about the sleep. Yeah, we already learned about sleep. So what I mean is sleep is between the difference here. Where is it? The rotors, the rotor itself is rotating, right? We say, if it's this n, I'm saying speed, okay? And here, stator windings, it also make it the armatures, revolving field in make, right? So we will say this is NS. So NN, and if NS is the same, we say synchronous. But between the differences, speed, we say this is silly, right? Yeah, this is a basic concept for the today what we are gonna learn. Okay. And this is the equation for the E's magnitude, what I mean, induced voltage, right? So here, guys. So as you guys, iPad this previous picture we saw DC excitation, right? DC, right? Excitation. It controlled the IEF's magnitude, right? And this green, I would say damper, damper. Okay. And here the black is field winding, field winding. Okay. This is a field winding. So here. So IF make it the pi F here, right? Pi F. And then it induced the EF, right? And this IA is we say load current, depending on the current. But generally our current is lagging because we consume the motors, right? So generally, yeah, IA is here. And pi A is also same amateur reaction, we also say. But what I mean is it's actually same and lagging current, right? And what I meant is look at that. This picture one is our general situation. You know what I mean? No fault, by the way, no short circuit. So our general situation is the current is lagging, and then the EF is this page looks like this. You know what I mean? But what happened? Number two picture. Look at that. So what happened here is because of a short circuit. You know what I mean? Actually, here's R little bit R also R, and here's L, right? So actually, it gotta be R plus JX. But in the case, we ignore this R because mostly JEX is it takes 90% or more, the values. So we ignore this time. So what I mean is if it's a circuit, this is just air circuit, right? So the amateur, look at that. If it's a circuit, the current is it was here, theta, right? It was here, but it gotta be almost 90 degrees. You know what I mean? Lagging. So we already learned the Lenz's law and the Faraday's law. Lenz's law, what is that? dt and d pi, right? And then here's minus, right? V or A, right? But what I mean is here, this time, number one picture, here's between damper and the field current, field winding, you know what I mean, field winding. They are synchronous, same. So that's why there's no changing over the flux here, this part, number one picture. That's why in this situation, in damper and then in field winding, there's no induced, current or voltage, you know what I mean? But in this case, because it just this point, what I mean, when it the short happened, the current is it changed, right? So that's why current is changing, which means the flux also changed at, at that time, you know what I mean? When they short like this. Like for example, if it's a 20 degrees, for example, it gotta be 90 degrees suddenly. You know what I mean? It changed, right? The values. So which means if the time goes by, if the flux is changes, what happened? Induced the voltage, induced the current is happened, right? So in this situation, in the damper, and then in the field winding, there's happened the induced voltages, induced current is made, because of the short circuit. You know what I mean? So look at that, guys, here. So what happened? So IF also it's a plus if we get it alpha more because it current is change, right? So there's two windings, right? Damper and then field. Also, since it changes suddenly, it affects these two windings. So from this alpha's angle needed, it added, you know what I mean? So that's why pi f is more bigger. As you guys see before, E equal 4.44 and F pi m, right? This is affected from this because of this short circuit. It's gotta be bigger. So which means E is gotta be bigger, right? And then what happened also in damper? Look at that. Damper is, I said, it's gotta be a breaker or it's acceleration, right? But what I mean is, in this case, look at that. The current is, it gotta be this downway, right? Downway. So downway means because of the inertia. Length, so if you guys remember, this minus is inertia, right? Inertia. So that's why this you guys green triangle you guys can see arrow. It made it, you know what I mean? But it disappeared soon. But because of inertia, it happened because of the course characteristic, you know what I mean? The length slow. So the dampers, you know, actually it made it this way. Look at that. So it make it the dampers windings, you know, induce the voltage or current. You know what I mean? It's affected also pi f more. You know what I mean? Pi f more here. Pi f means here, right? Pi m. So it made it more. You know what I mean? So I said pi m is pi f plus pi armature here, armature, because of that inertia. So it made it this way more. You know what I mean? So, but as you know, this way is inertia because of inertia. It happened, right? So it disappeared. So let's see what happened. First of all, you guys need to see is the tau. Tau. So we already learned about this. So for example, yeah. So the result I will say the sub you know transient state because of a damper, the tau is low. You know what I mean? So which means it disappeared early but sharp. For example, I will write down draw. So this red, you know what I mean? So and then here I will draw with the blue damper and then field here field. The tau compared to the dampers winding, the tau is big. Tau is big, so which means it's not that sharp. You know what I mean? Compared to these two. So like this. So if I divide it here, you guys can see. So the sub-transient state, because of dampers, tau is low compared to the paired windings. So that's why it's sharp, the lead, right? But it disappeared early, you know what I mean? So we, in the sub-transient state, we include mostly the dampers windings, it's impacted that period. But in transient state, because of that time the tau, dampers tau is disappeared already, right? But still left the field windings, you know what I mean? armatures is still left. So that's why we say transient state. It's effective because of the field windings. You know what I mean? Current or flux, right? So in this, where is it? So as you guys can see here, so subtransient period because of the dampers, low tau, it's included this, it impacted this period, the dampers, and here transient period, there because of the what is that? Field windings, so impacted here, and then steady state period, both of them that disappeared. You know what I mean? So actually, this access, you know what I mean? Access is just Ohm's law is I equal RV, right? But we generally think we are using voltage system. This is a constant value, right? Plus minus 5% constant value, right? But we think why current is changing. So we have to explain the R's change. You know what I mean? So in this case, R is a jet. You know what I mean? XS, right? XS, right? So what I mean is not because of the access, because of suddenly the EF is changed, right? Because of the armature, no armature, because of the field winding and the damper winding, they induce the induce the voltage. You know what I mean? That's the way is the same way. You know what I mean? So let's do a quick review a little bit here. So because of that, you guys can see here this picture. It was the first picture. It was like this. Number one picture, as you guys can see, IEF just induced the pi F, and this is like this. So damper and then field winding, there's no induced voltage. But because of a short circuit, suddenly it changed these angles, right? Alphas. So because of that, it induced the both of damper and then field winding. It affected both of them. So because of the Lenz's law, V equal minus dt d pi, it induced, you know what I mean? Because of inertia, it made it from the damper to here. But suddenly the pi f is gotta be more bigger because it added, you know what I mean? Because of inertia, but it added, you know what I mean? And then the IF, field current also induced. So IF is bigger, which means E equal, I said 4.44 NF. And then pi m. It's gotta be more bigger suddenly, you know what I mean? So we divide these three sections. Yeah, today's lecture is done, guys. Thank you.